Yeah. This meeting is being live streamed. Got it.
Yeah. I already covered my face.
Hello, Twitch. Hello, Twitch.
I'll see. Are we there yet? Okay, that looks better. Cool. Yeah, and the chat is open. Yeah. Well, yeah, let's just wait 2 minutes, and then we can start.
Have there been any updates, any new versions of Lean? Oh, I thought the nightlies, aren't there? Okay. Not an actual release since August.
Yeah, I fixed all the versions in the build now. So.
Oh, okay, good. So we're fixed on the nightly.
Yeah, an older nightly. So something
older nightly, okay.
Yeah, that something that the extension can also understand, I think. Yeah.
Yeah, there might be something fishy in my setup because when I go to the lakefile.lean, it tells me there's an error. It's like default target thing.
Okay.
Unknown attribute. So hopefully there's nothing fishy.
That's a version mismatch.
Yeah, it looks like it, doesn't it? So why isn't it not using the version from the file?
Okay, so you can do, I think, Command-Shift-P.
Yeah.
And
Lean. Oh, you need to tell it to update itself or something, don't you?
Yeah, you can say select Lean toolchain. And then you can choose the right one.
Oh, can you show me the command again?
Command-Shift-P.
Yeah, Lean4
select toolchain. So you have to be in a Lean file to do that.
Yeah, but that one that you showed.
Yeah,
So
I've got info. Oh, maybe because I'm in the info view. Ah, right. So if I'm, it's showing me some of them, but not all of them. Lean4, okay.
We ought to update the plugin.
Select Lean toolchain. 21st of September. Okay. Right. Now if I go back to, yeah, that's fine now. It's using the right thing.
Okay, then I think we can start. So
yeah,
today we'll, to anyone who's watching, today we're going to try to create a class for a Magma, a Semigroup and a Monoid. And these names sound pretty intimidating, but they're actually very simple things. And then we're going to create an instance of these classes. And this is going to be of type ordering, which is just less than, equal, or greater than. We're going to show that this is an instance of, well, there's some function on this type that is an instance of Magma Semigroup and ordering and Monoid. And maybe we'll get to using thunks as well. But let's see how we go. So Paul, do you want to take over?
Yeah. Sure. Okay. So as nominated scribe, so I'm just looking up the documentation for defining classes. So what do we want to start with? We want to start with a Magma.
Yeah. So as far as I understand, a Magma is just a class with a function that takes two values and returns a value of the same type. So it's just a binary operator.
Right.
That's my understanding.
Yes.
So we need to come up with a name for this. And some people call it Mapend in Haskell, but we can, maybe someone has a more appropriate name.
Something like this.
Yeah, but I think we have to use the type, right?
Oh, sorry.
We introduced.
Well, what's the convention? Do we use uppercase or lowercase?
We use Unicode. So we
Oh
use
God, right.
backslash,
So how do I do this then?
backslash a. I will give you a space. Yeah, that gives you an
Oh, so
alpha.
I've got to do /a space and then backspace.
Yeah. Well, only because you're filling it in. Like, if you were just typing, this wouldn't be,
Oh, okay.
this wouldn't be a problem. Yeah.
Okay.
So now,
So what else did we want?
well, maybe as practice, we can make an instance of this already for ordering, just to show.
Okay.
So we have.
So I say instance.
I just want to like bring in the function from last time. What I can't find. Oh, here it is. So this is the functional ordering, and I think we also need a better name for this function than less-than. But so it takes two orderings, and then if the first ordering is equal, it defers to the second ordering. It just returns the second one. And if the first one is not equal, it returns the first one. So basically, this is a way to short circuit a comparison. If you were comparing many things and you were chaining them all with this binary operator, then you could short circuit and not need to compare everything if the first thing isn't equal.
Okay.
And this way you can do cheaper comparisons first. So it would be like, if I have this large structure, then I would go, okay, if the first field name, say, is not equal to the name of the other field, then just return if they're less or greater than. Otherwise, I have to compare the next field in the structure and continue.
I think that's also called lexicographical order.
Yeah,
Right.
okay. Yeah, that sounds right.
So we've got, it's basically a way, if you've got two orders, you can create a lexicographical order, which is basically what you do in a dictionary as well. You first look at the first letter. The first letter is the same, then you look at the second letter. Second letter is the same, you look at the third.
Cool. So maybe that's a better name for this function.
Yeah, something like lexicographical or some.
I don't want to spell that all the time though. Like, maybe
Just say Lex. That's what they do in like singular or something.
Okay, nice.
Does the alpha symbol is a kind of convention? Is that a convention?
Yes.
But it doesn't matter which.
No.
So, what about the mapend name? This seems to be hinting at some properties of the operator, but it doesn't have one.
Yeah. Do you have a suggestion for a better name?
No, just a generic one like OP or something similar.
Yeah, OP.
I think I thought the M for mapend was probably for magma, so magma append, but I don't know if that's actually true or not.
Yeah, but it's not really an append function. Well, I mean, it may not be.
Well, if we're going to go Unicode, we could do dot. What the hell?
Oh,
We're not allowed to
not
do
accepted.
that.
Why not?
And would it be
What's it
infixed?
say? What
That's
did it say?
also,
Oh no.
Expected token. Bad. Okay.
Yeah, I think it's already used quite a lot. Yeah. Right. Cool. Yeah. So at least now we have all the syntax under control.
Info thing. Should it? Let me have a look at the Zoom chat. Should the info view?
What do you?
Okay. So my info view doesn't tell me anything anymore. My info view.
Yeah.
I'll have to look at your
Yes.
output.
Yeah. You have to ask me where to go. Sorry.
No, I mean my info view doesn't give me any information on mine.
Yes. Yeah. So you have to ask
I
me
think it was before.
where to click, and I'll do it.
Okay.
Yeah. Sorry.
Right.
Yeah. Good start. Seemed quite easy. So the class is just an interface or abstract class, depending on which language you're coming from. And instance is just saying, well, yeah, I implement this class. So ordering implements Magma and to do that, it only needs to provide a function for op, which is legs. And then the type is ordering. So it's a function that goes from ordering, well, it takes two parameters, ordering, and returns another ordering, which is exactly what legs does. So cool. So now Semigroup is next.
Okay.
And
So we can. So can you say class, and then what is it? Start with a Magma.
Well, you can say it extends Magma later. So maybe.
Okay.
I can give you that.
Well, that's for instances. That's for instances. I'm trying to see what, in the documentation where it says.
No, for classes too.
Oh, okay.
Yeah. So if you.
Which doesn't use this square brackets thing.
I think that's if you want to say.
Well, that's for chaining instances.
Yeah, I think that's for instances. Yeah.
Okay.
But maybe.
Yeah, I can't see in the documentation,
but I can show you. It would be something like on line 7. You would say something like this.
Okay.
Right. But yeah, obviously not. Magma can't extend Magma, but.
Oh.
Yeah.
Hold on, let me go back to the.
So Semigroup has one property, right? Well, correct me if I'm wrong, right? But I think it only has the property of associativity. Because basically,
yes.
Basically saying there's.
So it's just an associative Magma.
Yeah. There's this binary operator, and the binary operator is associative, and that's all it is saying.
So we need something of type. So.
Yeah.
So what do we put? So we want. OP. X. Y. OP. Z.
Yeah.
OPX. OP. Y. Z.
Yeah. I think just the Z here.
Oh, thank you.
Yeah. But yeah, so this is basically saying it's associative. Yeah, we just need to. I can introduce the variables if you want.
So how can we make OP infix?
Yes, but let's do that later, if that's okay.
Okay, sure.
Yeah, there's one thing I think we'll stumble upon if we do it too quickly. And I just want to see if we don't stumble on it. If we do
So
it
is
this way.
ASOC, do I need to give it the type? Can I just put the, yeah, how do I
Oh.
introduce X, Y, and Z? Can I do it here?
Yeah,
I don't know, my editor's not telling me anything anymore. So I have no idea whether it's working or not. Let me go back to the Zoom.
I think this worked. Look at that.
Hold on. It's not complaining.
Yeah,
Okay.
but look at this. Like it worked.
Yeah.
That's how it's strange.
So I did.
Isn't it?
I wrote it like this. Let me just show you the alternative. But I'm quite impressed that that worked. I went for all.
Yeah.
X, Y, Z. Then colon. Yeah, I did.
We've got 2 colons here. Is that?
Colon. This and then comma. Yeah.
Right.
And that did the same. So these two are equivalent. I think you could have also gone like we could comment this out again. We could have also done this. I think this is the same. Right. So
Yeah.
so all of these are exactly the same. Which is interesting.
Yeah.
Yeah. So yeah. Pick what you would prefer.
Oops. Just click-
Walter,
just click
or I saw somewhere like this syntax universal, like to denote variables of that can take any type. Can you try it and see if that works? I don't remember if I think it was universal. Yes.
Okay.
Where would I put it?
Before, like before the class Semigroup.
Oh, just like this.
Yeah.
It's complaining. It's telling me that unexpected command.
Or just one argument, or
If you do this, just one.
no?
What about at the top? No.
No. Okay, let me check it out again. What
I
is
also remember this command. Was it? What if it's you?
universal?
No.
It's similar to the variable in Agda.
Ah, there we go. Universe.
Ah, universe. Okay.
Yeah. Okay, but then we can. Sorry, Paul. Is it okay if I do this?
Yeah. Go ahead.
And then okay, then we have our alternative, which would just be this, and well, I wonder if we even what happens if we do this.
No way, but universe is
do
not universe
So,
is like
even if that
is a type. You look is the smallest type that you can have, and then you define another type is like containing that one. You can define infinite type in Lean, if I remember correct. I'm trying to look at the.
Yeah, so this universe thing is usually used if you want to say type X.
Yes.
So if you want to indicate
Type
which,
1, type 2, type 3.
is that for the okay?
Yeah, which type universe this is in. This is usually what it's used for.
You can do something like that.
I think the only reason it's working now is because it is inferring X, Y, and Z needs to be parameters here.
Do they have any keyword for what I wanted to do, like introducing these variables?
Probably, but I don't know.
So
Okay.
what
You should see type is type 1. If you put like here type, as you were saying, if you put this type 1 here, this is becoming type 2, stuff like that. Is like, and the biggest the number, biggest the type.
Oh, yeah. I found the syntax. Let me paste it.
Okay, sorry, I'll go down.
No, that was good. Yeah, just if you want, you guys can turn on your camera because at the moment
Nope.
when you look at this, when you look at the stream, there's just this no one and a voice.
The disembodied voice.
Yes, it takes it that there was a voice. It looks pretty, yeah, scary.
Just because I have the monitor twist, so my camera is on the computer and I use the big monitor, so you will see my profile.
Variable.
Profile is still good, you know. I like
Yeah,
your
I think this is what I wanted.
Okay.
could we try and define the associativity property as a function and then use it inside of the class?
Yes, but yeah, it's just this variables thing is kind of interesting, right? Just take a moment here. So yeah, this doesn't work. Maybe variable does. Yeah. Then maybe do you also need to do this here? I think this is the syntax, right? And you say check X.
I just copy and paste from this website that I paste on the chat. We're not using the chat on Zoom, right?
Yeah, I'm not using the chat on Zoom. I can't. I'm sorry.
Right.
I think that might be Lean4 though. That
Oh
you're-
yes, probably.
But,
Yeah.
but what do you
But-
want? You want polyformic type?
But now it is working. I just fixed the syntax here, and now.
But now that Isasok is complaining about X and Y.
Oh,
Yeah.
good.
Oh, because it's type
Yes.
universe mismatch.
Okay. So what if we do?
I don't know if we want the semigroup to have a type universe.
Yeah, we can do type U. U is usually introduced. No, but that's still.
But what is U? It should be a universe, right?
Yeah.
I think you deleted.
Yeah, but I think it's universe U is always like there.
Ah, okay.
But we're gonna.
Yes.
So
it's still
also like I'm not sure if the type should be a parameter to the class. Why is it not? I see. Because I'm used to having like Magma, you have the carrier set inside as a field, and then the operator. And then you have the is Magma, which is, or is Semigroup. And there you have the properties and the type as an index.
Okay.
Is this
So
the same or?
So Magma has
Yeah,
no
I think those
properties,
are.
right?
yeah, okay. So in Semigroup, like
I think
I'm
this is
saying I'm not sure what are the advantages of having the alpha as a parameter rather than a field. So at least I'm used to seeing when you have the parameter, you say is semigroup or something like
Yeah.
this, but maybe it works different in the.
I think that's a design choice for sure. You can do it in your way.
Do you
Or-
know what are the advantages of that, Jonathan?
I think
No.
is the separation between the notion of defining a thing as a structure or as a property.
Right.
So here you are defining as a property, and what you are suggesting is as a structure, I think. Yeah, but that's the topics related to that discussion that you were saying.
Okay.
Yeah. Maybe I can find something for that.
So the only reason I don't know if this will work is with the extends Magma. That's But it might still work. I just don't know.
I still get an error.
So do we want to figure this out, or do we want to maybe prove that the operator is associative?
I'm just interested what exactly. So Jan, were you saying like for Semigroup, you'd have it as a structure? Semigroup? We still have to have the type variable, right?
No.
In order to have the field. Maybe
Well, I mean, you can have it. I don't know if Lean4 has dependent records, but if it did, then you can have it as a field.
oh, so yeah, I don't know what it would look like. I'd have a structure which have a carrier.
Yeah, and that is the type.
That's the type. Okay.
Yeah. Yeah. Well, without.
But then that's
Either use alpha or carrier. Would you prefer carrier or alpha? They're both fine. But no. So you remove alpha colon type from the signature. Maybe, yeah.
Yeah.
I'm not saying this is better, but
no, I'm just interested.
I've seen it
so then
in
what,
some place.
Oh, then we have carrier type.
Yes, and then the operator is from carrier to carrier to carrier.
Yeah.
This is like
see if it is happy with it. Oh, what? I can't see the errors. Hold on. Go back to Zoom.
You have the same name repeated. Semigroup.
Oh, right.
So it worked, right?
Maybe.
Yeah, I mean, maybe internally it's just the same because this is a.
Well,
the type class will be converted to some structure at some point, won't it?
I'm not sure about that.
I think the problem is that we use variable instead of def. With type, we should define type.
Maybe
here.
If we make an instance of Magma struct, we will know if it really is the same. No,
we can't say that though, can we? So we have to, how do we instantiate a structure?
Like just
it's a regular function.
A populated structure.
Yeah.
I'm confused now because what does this syntax even mean? Because when I look at examples of declaring structures, it doesn't look like that at all. But
no.
You have
This is the preferred way to declare structures.
Oh. You've got like double.
Got two fields.
I can't read this in the documentation. For example, structure point, and you have this double colon.
Yeah, but there should also be the same, like, you should also be able to find this.
Oh, okay.
I think we can say
so it's like double colonies for constructors and single colonies for fields, or how does it work?
Just go.
Yeah. Should be.
Still MK.
Not init.
MK, is it?
No. Oh, they didn't go with MK. Is it? Mm,
Two. Okay, no, it's
I don't know.
not. Oh. Actually, I totally cheated because it's in the documentation. I was looking for how to define a structure,
Mhm.
and there is the semigroup.
Yeah, no, don't copy that.
Cheating. Yeah.
Just to tell you, the first part, despite the name, instead of they use mul, is correct. You just need the then associativity.
What? Failed to be synthesized. Oh.
Oh, it doesn't change anything.
What I'm saying, what I'm just confused by what I'm reading in the documentation.
Yeah.
So it's a structure point, and then it says.
Does the
It says
matlib
eval.
define these kind of structures?
Here we go. Sorry, it was MK.
Yeah.
It wasn't
Okay, but you got derived
How can I-
repro. Okay.
Yeah. You just have to be able to print it. That was the error. So
they
My
could
bad.
show type class.
Oh, that's good. That's good. Not
Yeah.
going insane. All right.
why did I think it wasn't MK before? That's so. Okay, sorry. But yeah, so we can create a magma struct now if you want.
Okay. So let's say I can say plus or something.
Mm-hmm.
Go to Zoom.
You can also just do ordering
Complaining.
and legs. Maybe that's easier than finding what add is called. Yeah, so cool. And then we can just go. Okay, yeah.
Print functions.
It can't print functions. So basically we can do is check the type. So yeah. This worked.
Yep.
So I think why I prefer the class here over the structure is that we can have instances of the class. Right, so we can have like ordering be an instance of Magma, where right now we can have, with the structure, we can have ordering be, well, not a type instance of Magma, but a value instance.
Yeah. I think they are used in different contexts. Like there are some properties where you need to reference the type. In that case, you need the type in the as a parameter. But there are some instances where you don't want that, and then you can use a struct. But yeah, let's use the class now for now. And also there are times where you want to talk about the actual operator, so then it's useful to have the operator in the signature as well.
Yeah, but the operator is always in the signature, right?
But by the signature I meant what you have before the where.
Yeah. Yes. All right, but yeah, still very interesting.
We can remove this for now.
I think we can keep the magma struct. Like that was interesting, right?
Okay.
I'll just move it here out of the way. I think it's still
Yeah.
valuable to see that these two things are almost they're equivalent, just different use cases.
Yeah, but it's an argument in favor of having the operator in the type is, for instance, you can have, for instance, for natural numbers, you have two possible, well, at least two possible instances of semigroup, right? For addition and for multiplication. And if you don't have the operator in the before the where, then you can only define one of those. I think maybe I'm wrong and it doesn't work like this, but I would expect it to be like that.
I've seen in Lean like that they have this thing where they have a multiplication instance and an addition instance of semigroup.
But with this definition of semigroup, you can only have one of those, right?
Yeah, so I can't remember how they did that, but I agree with you. So, but yeah.
Okay, no, let's continue like this. I mean,
yeah, so
I don't think we'll have that problem anytime soon.
No, but I think it's still a good point.
Yeah, so they've got, I'm just scanning through the docs, and they've got like scoped instances, local instances, default instances. Maybe you can have like particular instance scoped inside a namespace, and then a different instance scoped somewhere else.
Well, we can just check, right? So we can just make Lex2 does exactly the same thing. Well, let's make it do something weird. Apparently this is fine.
Well,
yeah, good luck to the type checker. I don't like I think here you would have to give it some hints to know which one to pick, right? Because this is just ambiguous.
Yeah.
Do you see, Jan?
Sorry, see what?
You see, like here, I made 2 instances of Magma.
Oh,
Uh,
yes.
One is with legs, one is with legs 2.
So
Apparently, this is fine.
then I had the wrong intuition about instances and classes.
Me too.
I assumed it was a bit like Haskell, but it's not.
Yeah, I think it's yeah. They go on about it being more powerful or very powerful, and I didn't take them very seriously until now.
Well, I mean, we haven't used them; we've just defined them. So
No, that's fair. That's fair.
Oh god. So we got
I don't know if
Wow,
one is
okay,
ghosting the
yeah.
other. Or creating actually 2 different instances.
yeah, you can assign them priorities, and
Yes.
it seems a bit crazy. So you can say I've got multiple instances, but try this one first, and then try this one.
that must be fun to debug.
You can change the order of the type class instances are tried by assigning them a priority.
Yeah.
Oh.
I think these are a bit,
This doesn't seem
less computer
great.
science, more really for LeanProver.
I think having like the scoped instances, you can have there's something called scoped instance. So you can have a namespace and then say that this instance is scoped to this namespace. So you only have, you can have like, how do you close a namespace? Oh, end. So you say we could have like, if I'm reading this correctly, so we could have namespace like lex, and then have this instance end lex. And then you have, instead of an instance, this would be a scoped instance. So it'd only be available if you open lex. And then
Yes.
similarly, for this one, you'd have this scoped inside of a lex2 namespace or something. So you could
Also-
have like, for different monoids, you could have like different
Yeah.
namespaces, perhaps.
And there's also
Maybe that's how you
section,
can
I
get away
guess.
with it.
Yeah. Can also section, you can use it.
Yeah, as far as I understand, section is just a namespace without a name. Prove me wrong.
Yeah. But you probably want to name them here so you can, I could say
Yeah.
like I want the addition monoid or the multiplication monoid. I'd want to open that particular namespace.
Yeah, to me it just seems like a duplicate, unnecessary feature
Hmm.
to have sections if you have namespaces, but I think.
You can write a name, so they have name in the section.
Oh, okay.
It might be like cock then, they're just like synonymous. Cock has like lots of synonyms for the same thing. For the theorems and example and the lemma.
Then I don't remember if you actually put the end section or end my name.
So we have a namespace nested inside a section. It works.
It seems like
A good test.
well, it seems like I'm suspicious now because everything seems to be working. So I'm very suspicious.
Oh, you can.
It's like I found an article
This
this week about 93% of all like if you fire paint randomly in the wall, then 93% of these paint splatters are actually valid Perl programs if you convert them to text. So like, I feel it's a bit like this.
Okay. Look at this.
So we just put random stuff. It's just okay. That is not valid. Good.
Yeah.
Invalid keyword. Perfect.
It's still working.
Well, following the manual, usually section is when you, because you can declare what as we did the variable. So you want to let me copy paste is easier. The code from the manual. So you want to create the like this. So you have something to do with some variable, and you want to use it in a limited scope, and then you want to reuse maybe the same variable down there, because as I know 3-4 Greek letters, so I need to reuse them, and the section will help you to do that. And logically, the namespace, maybe because we are coming from a computer background, is instead the higher level to, I don't know, share a library.
Yeah.
Let me check in the meantime the namespace.
Yeah.
Namespaces and sections serve different purposes. Namespaces organize data and sections declare variables for insertion in definitions.
That's it.
Okay. Fine. Okay, that's that the version. Where were we?
It's so close to each other. So it's just Again, I can always
They are
use
really close. Then it says, in many respects, however, a namespace block behaves the same as a section block. In many respects.
Yes. In many, that's so
In
well
many
defined.
respects.
This like you have all these like perfect definitions, and then it's like, yeah, namespace
in many
sections
respects.
kind of the same.
I'm not going to tell you exactly in which respects they're different. Just
I think
Yes.
they are different that you can open a section, I guess.
Oh, you can't open a section? I thought
No.
it said you could. Oh,
Yeah.
No, you can. So the idea is the namespace should reduce the scope and then export the, what you define, while the section is just a way to reduce the scope.
oh.
This is my understanding.
Right,
Yeah?
so you can't open them. Ah, right.
Yeah.
That would be a major difference. Okay.
And I think you also cannot do the section name dot stuff,
Yes,
which is
precisely.
similar to opening, but so it sounds like everything that you have in a section is not accessible afterwards.
Section in Las
Is that
Vegas.
wrong?
What in section stay in section.
But then if you what's the point? Oh, you can't.
Yeah, that isn't.
The part of this manual is very whimsical. Like at the end of it says, when the section is closed, the variables go out of scope and become nothing more than a distant memory.
That's very like.
But okay, we just this goes here, right? And then
So variables disappear, but maybe not definitions.
Yes, yeah, I just checked something, and the definitions do not disappear. So
yeah,
you can do
that's
something like,
good.
so they've got, for example, section useful in their documentation. Then they
Mm.
introduce a few variables and define a few functions. But then afterwards, first I did check useful.compose, but that doesn't work because useful is not a namespace, so it's not being prefixed. But now I tried to check compose, and then it's I can find it. So the variables you define in a section disappear, but the rest, the things you define, stay. Looks like.
yeah. So here is the example where we have a definition M, and we can reference it outside of the section legs.
Yeah.
But I guess this is so I guess this section is not really doing anything yet. But if you were introducing variables there, I guess that is the point of
Yeah.
Yeah, you can't do that, but maybe.
Oh, I just want to try. Wait a second, if I can. But really simple. Because otherwise it's a bit weak. no, this section.
Yeah, so this shouldn't be available now, this
So
XX.
the depth, I think, is different from the variable.
Yes.
Yeah. So you can only
So-
use the variable inside of the section, but you
Yeah, so actually
the depth is
sections leave for scoping the variable, nothing else look like.
Yeah, I think that was the perfect sentence. Sections are for scoping variables and nothing else.
Yeah. not like in many respects they're the same.
Yeah,
That's the only respect in which they're the same.
that was beautiful definition. Like,
Okay, that's cool. I never use it, and you see, as you said correctly at the beginning, Walter, banging our head, so maybe eventually we get something out.
no, that was good. That was really good.
Okay.
Okay, clean up a bit, I guess.
Yeah. Got where we were.
I think we were trying to make a semi-group.
Oh yeah. Where's it? We've lost the class, right? It should say class.
Ah, you're done
I
here.
can't see class semi-group anywhere.
Yeah, we lost that.
Where's that gone? We lost it.
That was my bad. That was probably me.
In the documentation say that structure is usually preferred to define algebraic structure, maybe.
Oh, really?
I don't know.
Where does it say that?
Theorem proving in Lean, page, don't ask me, 108, I guess. And this is where I found actually the definition, the structure of semigroup.
Oh, then we shouldn't look. That's cheating. That's...
I'm not looking at. I'm looking at the definition before.
Only I'm allowed to cheat. No one else.
Okay. That's fine.
I feel bad now. This is so.
No, let's do our way.
Well, Jan's arguments are correct.
And I'm not copying
argument from authority here.
No, let's go our way. No, so the good thing so.
Oh, where did you go?
Oh, I did. Sorry.
Yeah, that's good. Okay. And now I really want to see it. I haven't seen it.
Should I copy that too?
Yeah, screw it.
It's exactly what Jan was saying. So I think you're okay.
Oh gosh, sorry, it went a bit bad there. Let me put control. All right.
Yeah, so we've got carrier.
Exactly what we are
and then
doing.
we've got, yeah, this is exactly what Jan was saying.
No,
And then they put the ASOC, you put the associativity law in the structure as a field.
Yes.
Is that what you're saying, Jan, as well? Or I thought you wanted to put the externally.
Well, it's essentially the same, but you can have a definition that is ASOC, and then you use it here in the type.
Got it.
But it's
it's going to be more stuff potentially that is associative.
Yeah, and well, I guess this way we can use a function on a type. So.
Okay.
I think it's interesting to define these kind of higher order properties as separate functions.
Can you also say that, well, how would like, so we would also have a structure for Magma, right? Like we do. How would this work? Like, if you wanted to
Well, to compose, you'd have to have like a magma field here, I
Yeah,
guess.
compose. Yeah, that's the word.
And you could refer to OP in the Mullasock.
Is there any way to extend a structure here? Like, I think there is a way in Lean, but I'm not sure. Like, just adding the muls a sock to the previous structure definition that you have.
I don't
Oh,
know.
it does have inheritance.
Yeah,
Oh.
like oriented
structures?
programming.
Yeah.
Oh,
So you can say
interesting.
extends point.
Oh, let's do
So
that
the
then.
example. This is the. I'll put the example here. Whoops. Oops.
Yeah, sorry.
What is this saying? This is. Oh yeah, we can extend
There we go.
a structure. We can extend magma with this Mullasock thing.
Mhm.
But can we refer to the OP? Presumably.
Nice.
How do we reference the?
I
Oh,
think,
well, this is called OP.
yeah, just say
changes them
OP.
all.
And you prefer OP?
Yeah, yeah.
I don't know how to do. I don't know how to find and replace them.
Oh, I can do that for you. Yeah.
Nice.
Huh.
Oh,
Great.
this extends feature is very nice actually.
Yeah. Does the underscore have any meaning here? Like a hole or?
I think it's just
Where's
a
the
Inline?
character.
underscore? Where's the underscore in this?
In is ASOC, I think it's just a regular character.
Okay.
Oh yeah, yeah. I think this is just part of the identifier.
Yeah, it just put me nervous.
Oh, and it has multiple inheritance. Oh,
Oh,
fantastic. That's the last time I used multiple inheritance was in C++.
Yes, sadly.
That's
How did it
wonderful,
go?
isn't it? Wonderful.
Yeah,
Oh,
this is a
please.
game changer.
Yeah,
It's a
We don't
game
have it in
changer.
Agda.
in negative.
Well, I don't
Negative.
think it's such a good thing. Yes.
No. But
Yeah, this makes me reconsider this lean choice.
Yeah.
actually, because Lean, funny enough, is written in C++.
Diamond dependencies.
yeah.
Yeah, there's
Yeah.
a lot in math.
Like Python has multiple inheritance as well. I think people wish they didn't have it.
Yes, definitely.
Yeah. I think lean can always find someone who dislikes a feature in lean. There are so many. Yeah. So
Well, at least with multiple inheritance, you don't have to use it. So you can just stick to single inheritance.
oh, sorry, wait. You can everyone you meet will hate something in lean. There are so many people.
Oh yeah, for sure.
I think you can like at least 50% of people you can kind of wipe out with the Unicode characters. You can just go like, okay, they'll hate that. Okay, now the other 50%, like let's go. Like I'll find something.
Actually, I find very cool the fact that you have the Unicode for all the character, also the like the for all or exist.
I was against it until I found how easy it was to type it.
Yeah,
And now,
that is the main thing. Yeah.
and if you don't know, most of the time you just try to use the word, the slash, and then the word, and it's kind of
it's weird how intuitive it is. It's really, yeah. I was like, I'm really gonna hate this Unicode thing, and then, okay, 2 seconds in, oh, it's fine.
second you were playing and love it.
All right, so we define semigroup for doing what?
Ordering.
Well, we want it for the ordering. Yeah. Yeah.
For the ordering.
It's the bonus. Yeah. So
I can't just so say I have an instance of Magma.
you have to do MK.
I have to deconstruct it in order to make an instance of Semigroup.
Well, we are using structure, so we get to use all the nice structure syntax
Oh, that's true. Okay.
for a change.
What are we doing here?
But we can also like define the final structure, which is the monoid, and then go and create instances of them all. But your choice which way to go around.
Okay, let's do.
Yeah, to anyone doesn't know, like a monoid is just a semigroup with an identity element.
Identity.
So which means that taking
Oh no, unit.
Unit?
well, yeah. Well, unit has a meaning, right?
Identity as well.
Yeah, that's true. That's true.
Well,
But yeah, you need a left identity and a right identity rule.
Oh, we can actually use a Unicode symbol for a unit. Epsilon.
How's that?
Yes, then we don't have
Epsilon.
to argue about the name. That sounds great. Let's do that. I love this Unicode.
Yeah.
It just solves so many problems.
Yes.
Well.
So the left identity.
Epsilon looks too much like analysis for me.
Well, you can now just say the unit, the op,
can
unit,
be like a bold number 1.
and x equals x.
Well, actually, the epsilon is usually for monoids units because well, the first monad, the first monoid is like a list, a concatenation, and the empty list is usually written in textbooks as epsilon, or the empty things. So you want to always concatenate the empty with everything and preserve the list. So, well, epsilon is a good symbol anyway. But you can put alpha.
I think we want alpha.
Wikipedia also uses an E. I think it uses.
Yeah, mathematicians will use E.
not
That one, yeah.
Oh, it doesn't use that one. It just uses.
Mathematicians will use E.
Yeah, an E in italics.
Good.
We need a right identity. Yeah, so basically if you put this operator with the identity, then you get the other thing. Well, that.
Okay, so if we want.
What is comments? Oh.
We should put all the other options there. Epsilon. Dot. ordering monoid.
Yeah, okay. Yeah, maybe you can start with ordering Magma, and then we can see how we can maybe use some syntax to make it easier to compose them.
This is like ordering. Ooh. So label it with Lex.
Cool. Oh, you can also use this curly braces, like just to like there's an alternative. I just want to.
Yeah.
So that is perfectly correct. You can also say. Oh,
I have to put,
well,
do we
I
get rid of the
saved it.
MK?
Sorry?
Do we need to get rid of the MK?
No, apparently not. But
Uh,
I did something wrong.
The curly braces expected type is not of the form.
It should be
It
should
is
be rounded break, normal bracket. Actually, you can also
like
without.
this is
Yeah.
valid syntax, apparently. So it's kind of
what's it actually say? Invalid expected type is not of the form.
invalid
What?
notation. Like it's not even.
Can you put holds?
Doesn't show me all of the error message, which is annoying.
Well, here now.
Even when you click on show extra, it still puts the ellipsis in. It's not very. Let's see. Yeah, look, this invalid expected type is not of the form C and then ellipsis, and then you click view problem, and it still has the ellipsis in the error message. Error message is truncated at some other point in the compiler.
Oh, I see. Even worse. But what is the problem here?
I don't
Oh, actually,
follow.
maybe that is the full error message. No, it is the full error. It's not of the form. What is C? C is like the constructor.
Okay, what about
I don't know.
this? This still a problem?
But now he doesn't know.
What is the type? What is the
presumably.
type of ordering? Is type?
But it's complaining about the notation.
Yeah.
We haven't got
Yeah.
to type checking.
Yeah, I don't understand the error message.
Well, now, okay.
What?
But yeah, because the point is that when you use the square bracket, is a structure.
Don't you?
So no,
Don't
you
we
can
have
do-
inference for the?
no.
I don't understand.
Come back where you were. .mk, but then remove the bracket. You can do like this. MK. Sorry.
Oh, wait. When you do an alternative, maybe just
Like
That
this.
did work. Okay, that did work.
Okay. Yeah. And then
And if you remove the type annotation before the assignment symbol, but using the magma.mk, that does
you
work
can
as
do
well? No?
like this, but in this case, you should do like this. Because like a new instance, this is the problem now ordering. I don't know why. Expected. Okay, understood. Maybe just need.
Yeah, so here we can't put the. Yeah, we
Without
can just
the
pass the
OP.
arguments in. Like this is the on line 50, line 53.
Maybe without the parentheses. Yeah.
Yeah.
Okay.
But like this, you can do it.
That makes sense.
When you do like this, you actually pass another structure. So here you are creating another structure inside here.
You're creating another structure.
So the example that you share here, what was the blah here? Blah, if you've seen the example, this is a structure, this one, and this one is another structure, and this
So
is
blah
a
must
simple
have,
type.
yeah.
Yeah, this was my
Makes
bad.
sense.
No, it's that the documentation is starting from
That's a
giving
structure. So
parameter.
blah is a structure of structures.
Yeah.
Okay.
But what if you
Yes.
no, okay.
Yeah. So
No,
so
one.
these are the two alternatives.
Hmm.
You either have to indicate the type here for the definition,
Mhm.
or you can use, and then you can name things, and the constructor is inferred, or you have to use mk, and then just passing the parameters to the function, which is
Okay. Let's use this named version.
cool.
Use more the JavaScript or Python type instead of the Haskell type.
Oh look, Jan and Jonathan, I've been well trained. Look, I put my colons now. I'll leave a space. I
At
would
this point,
normally
I
do
just forget
this.
about it.
I normally do this, but now after writing Juvix, I've been trained to do this
Oh, why?
Nice.
because of this. This was
It's discipline.
yeah, because we could have we could have a colon right as part of the identifier.
Oh, okay.
Yeah,
I
I don't
see.
know if we did we change that. I don't know.
Hmm.
Now we need a proof in here.
Oh, now, so
So I can't just pass in.
I think
What
you
I'd like
can.
to be able to do is just pass in my magma.
I think
But
you can.
where would I pass this? But under which field would I pass it?
You could say to magma. So TO. Yeah.
Oh, really?
And then
Oh, okay.
magma. Yeah. Oh no, yeah, but you did it right. Yeah.
Oh.
To magma. And then you go you're ordering magma. And then well you need is a sock. But I think sorry. Yeah.
Hmm. What the hell is this two magma nonsense?
So this is
Maybe
like generated for you.
Oh,
make-
right, okay.
maybe it makes more sense to put all this stuff in namespace since you are repeating the prefix ordering. Maybe inside you can have definition magma or something like that, and semigroup
But we want to use them between each-
ordering dot magma later. I don't know.
Hmm.
Or are we gonna? I mean, are we gonna use this later, or it's just for fun?
No, we are. Yeah. I think we'll
Oh.
just use mono.
Or we can do also the later maybe optimization, no?
Yeah. Okay, that's a good approach actually.
No, just because it's really tricky to follow.
So what is this two magma gadget?
So
Is it syntax or is it what?
it is like by the struct, it generates
Yeah.
it for all the extensions.
Only for the structure or also for the class?
Oh, okay. So this is precisely sugar for the case that we're in, where you've composed a structure with another structure.
Yes.
Where you've
Okay.
done this extension, you get this gadget to magma to fill in the magma fields.
Yes.
Okay.
You can also fill them in one by one, like
Right. Sure. Well,
So
this is nice.
let me
Yeah,
just.
this is a bit I was worried about. That
I
you
think
have
it's good to
do
show.
this.
It's good to
Yeah.
show the alternative here, right? So we could say carrier order.
Yeah.
But what if you already define ordering like magma? Can you work with that? Since that's an
This is also perfectly valid, right?
So they're equivalent.
Yeah.
Oh, okay.
Equivalent.
Wow, it's pretty cool.
Yeah, that's nice. But
Eh.
how
But this
discoverable is
two
that?
magma
Like,
or two whatever is created only for structure.
Yes.
Oh,
Well, I assume because inductive has very little help.
yeah, inductive seems like it's bare bones.
Yeah.
Okay. Well, that's really nice. It makes the extension usable,
easy.
more easy to use.
Yes.
This composition style.
Yeah, when you go to something like ring or field, it would be very easy to not repeat everything.
Yeah, contrast with Java.
Oh gosh.
Oops. So
I think we can do the proof if we want, or we can first finish all the structures. And then...
yeah, so this one, monoid. We can do the same thing here. Do semigroup. Ordering like semigroup.
As will be. Oh,
And then we have these two fields which we need to fill in.
Oh, 3.
Can you do that for me? No quick fixes available. Yeah, but you know what fields are missing.
Oh yeah, it shows E, so that would be ordering.eq.
Yeah. Oops.
No. Yeah. And then his left identity.
Where is my curly brace gone? the perils.
We both typed it and then we both.
Yeah, we both deleted it.
He's like, oh no, sorry, I didn't want to.
That game could last a while.
Yes. All right. And we can fill in the proofs.
So def ordering is ASOC. So oh, sorry. So I don't want to say this. I want to say Lex is ASOC.
Oh, I know. Yeah.
Yeah. And then we want to copy this thing. And then
Yeah, replace
with Lex.
No, I can do that. I can do that.
Okay.
Oh. Here we go.
Bye.
Yeah. Okay, so what we learned last time, everyone wasn't here. At the end of the session, a lot of our problems came because we put by on the second line.
Yeah.
And Lean is kind of indentation sensitive. So if you put by on this line, everything kind of goes much smoother. You can put by on the next line, but then your indentation is very sensitive. Yeah. So that's something.
So now,
really?
yeah, right.
Yeah.
So you just need to remember to put by on the same line as the
same
type.
line,
and then life will be easier.
Yes. Definitely possible to put it on the next line, but just Yeah,
If
you're
you're a
gonna
masochist, yes.
you're not gonna have fun.
But how does it change? Or yeah.
Let's finish it like this proof, and then I'll show
Uh-huh.
you how you can also do it with by on the next line. Okay. It'll
Right, so
be
now I need
easier.
to look at the Zoom call window. Okay, so my tactic states I just have to prove. Now I don't remember any tactics.
Yeah. So we can do
Simple.
intros.
No, we should. Do you want to do simple first? Well, I just want to see if the. Oh, what's this simp all? Is that
So
the same as simp?
Simp. Hmm.
Well, this is not even valid. The internet lied to us.
They lied, yeah.
This is all I've been waiting for. It's just to be able,
Oh.
yeah. Hopefully, maybe it's that. Okay,
this is
No.
No.
this is valid.
valid.
Oh well, yeah, valid enough. So then we can do
Unsolved goals. Okay.
intros maybe.
Yeah,
Do you want to type? Sorry.
yeah. Let me go back to.
Or intro, I think. Or intros, yeah.
So what does intro?
Yeah,
what's it
yeah,
called?
intro just added
Maybe it
one.
has a parameter. No.
Yeah, so I did A as a parameter.
Yeah, it put a above the line. So yeah, intros maybe.
Mm.
Intros is for more than one. Yeah, I
Intros
can
and
see
then
that.
take all the premises. Maybe
But there is
yeah.
a plus close to the parameter.
a dagger. It's a dagger.
Yeah.
Is a
Yeah.
plus, it means that
What was this?
Lean
It's like a
infers something.
reference inside
Yeah.
the goal. Yeah.
It's like Lean infers something.
Yeah.
Like it did something for us.
So maybe if we name them, right?
Mhm.
I think because the problem is that
And we get proper names.
So daggers mean I named you. I generated a name for you. Okay.
So they have this convention that they don't like you using variables that you haven't named because it makes the
Very
proofs
sensible.
more unmaintainable.
Yeah.
Yeah, that sounds sensible.
Yeah, so I think they put the crosses there specifically because they're harder to type. Yeah,
Not for Emacs Pro Unicode user.
yes,
Child's
great.
play.
Yes, but, yeah. You know, with the every version they just change the.
Oh yeah, they should randomize it, shouldn't they? Shouldn't
Yeah.
even be every version. Should be every instantiation.
Oh yeah, a new Unicode character. Yeah, we'll turn the cross upside down.
You may want to do now cases on A.
Yeah. Do we have case? By cases or case prime
Case,
cases or by
cases.
cases? Just case.
Cases.
Cases A. Okay.
Yeah.
Braces, I think. No.
So now we've got yes.
And now you can you can do curly parens, or you can do backslash dot, and then you're in a single case.
Okay. So how can I?
What?
Well, you've done
What?
backslash dot, and now we are so we're focused on that one goal. We're focused on the first goal. Okay.
Yes. So this is good, but some star didn't do anything.
No.
So that's kind of disappointing, and also this didn't do anything.
This is a syntax error.
Yeah. So yeah. Thank you. But we can do.
Well, simp star must mean something.
But we can
Because
do
it's not. Yeah.
some lex,
Mm.
and that should do.
Oh, brilliant. Okay.
Did it do? It accomplished.
Yeah, did it? Yeah.
Yeah. So that's kind of annoying. We can't see it, but
Are
yeah, it's fun.
Are the C dots like bullets, like for items, or?
Yes.
Yes.
So we need 3 bullets, right?
Yes.
Yeah, this is the problem with Unicode. It's like
Oh no, yeah, it's
VS
backslash.
Code. No, it tells you. center dot. That's good.
Yeah. Cool.
But no, it didn't complete the. Did it?
I think so. Yeah.
Because yeah. So if this also works, then we can do the chaining thing.
Yeah, it worked. Yeah.
So we can do what's it? Semicolon?
It was, I don't know how to say it, was this semicolon.
Oh.
Yeah. Yeah, I mean, we shouldn't need this.
Okay.
Cool.
Good.
Well accomplished.
I don't get to say QED at the end.
No,
That's sad.
very. It's kind of
Or
annoying.
even Unicode box QED. No, it's not valid. We should submit a patch.
I think. I wonder if there's like.
But you got the smiley with the you did it. You know the
Oh yeah, we get emoji.
the emoji.
Okay, so our theorem is wrong because it doesn't fit this hole.
Well, I think it's just it has to be. You have to just move it up here.
Oh, right. Yeah, there's that.
Yeah,
You have to fix that.
Do things in the order of usage. So. Oh, the reverse of that.
Okay. Okay, so now we need, what do we need next? So we need EQ is left identity. For all.
// for all. Yeah.
So for all, do we need to put the type? No.
It's pretty good at inference.
So Lex ordering
Okay.
EQ.
You can also write just /all should do it.
Okay.
Let me check.
It's so much harder to remember though. So
Yeah. yeah, you work also just all.
Okay, cool.
So intro X.
Yeah. I think maybe now try simplex. See if it can figure this out.
Yeah, shouldn't it?
Nice. Yeah.
Yeah, so this is just behaving more like CBN in Coq, which is a relief.
Yes. Yeah. We're getting there. We're getting there. It's not exactly, but it's yeah, getting there.
And now with the star, that's what we need, isn't it?
Right.
If we can have the star thing.
Yeah, we need to figure out the star thing. Yeah. Oh. That's not proven. No?
No. Because the definition of Lex, I guess. Yes, it matches on the left-hand side. So
Yes.
this is classic, the classic, asymmetry.
Yes.
Yeah.
So then we should do cases.
Yeah.
To buy index.
And
hopefully you can figure all these out.
Yeah, I think you can just try to chain them and
Yeah.
see.
You can just compute these.
I think even Rayful might work now.
We should try that.
I think should really.
That's okay.
Where is
With one E, without the E, sorry. Yeah, cool.
What is just the semicolon? I don't remember.
So this semicolon says, oh, with the carrots, I don't know.
Yeah.
Yeah, those things. The pointy arms, the very angry man.
Yeah, I look like very useful.
I'm so angry. I punch all the goals. So yeah, it just applies it to all the cases.
Okay.
Yeah.
So you're like grouping together back. Cases separate and you're like union back? No, what is that?
It's like saying for every case in the list,
Okay.
say riffle.
Oh.
So
Okay.
for if ordering is so this, yeah, well, so these two are equivalent, okay?
Yeah.
Come
Yeah.
on, come on. So these two proofs are equivalent.
Yeah. And you can do also with the curly brace instead the dot like this, right?
Yes, you can do.
For the cases, no, okay, without. Instead of dot, you can put just curly brace. Oh yeah, okay. That is the notation that I remember. Okay.
Yeah.
I didn't know the dot. Cool.
Yeah, these all three are equivalent. Yeah.
Leave it if you no, for clarity and maybe help. Can we leave it? What do you think?
Sorry?
To leave this, maybe just this different notation, no?
Yeah, we have some examples here as well.
Okay. Oh yeah, I see. Yeah.
No, you're right. Yeah, we don't have enough. We don't have enough. Because we have none of the dot ones. So
Walter, I think I miss what is this argument to the tactic simp between the brackets?
so
Lex?
lex is our original function.
I see, but what is the
So you
what is the meaning of that? Yeah.
You tell it which functions to simplify. So which ones do you want it to try to calculate?
To apply.
So I can have actually a list of different kind of terms there?
Yes. Yes.
Okay. Thank you.
Yeah, no, 100%.
So is it terms or identifiers? The thing that you have in the list.
Good question. really,
I'm curious as well.
I think it's functions. Yeah, I think it's a list of functions.
Okay.
Function names, yeah. Well, you have to kind of qualify them sometimes as well if they're in a class, for example. But yeah,
Find a list
I'm not 100% sure, right?
I would guess that
documentation is not clear. Yeah.
you may, yeah, because you may want to use identifiers names as a hints for the tactics, which are probably just functions that try to inhabit some type, right?
Yeah. I'm guessing just that simp isn't that smart, but
yeah,
I can definitely think and cock this would be a thing. And hopefully in the future, lean tactics are also smarter. But
so you can give it a list of lemmas and definitions to unfold and compound expressions, it says in the documentation.
okay.
compound.
So you can just give it, yeah, I don't know what it means by that.
Composed, no?
Compound expressions.
Like
Yeah, but
any
it's not that
expression.
And you can also pass it in like rewrites. Yeah, I don't know what it means by, oh, right. So it's the asterisk means use all hypotheses present in the local context. So it doesn't, it won't add, it won't do unfolds. My reading of that. It will only use hypotheses with the wildcard symbol. It won't do unfolding.
Aha.
Does it
You have
say
to
if
specify the functions you want to unfold.
does it say if the order matters?
That's a tricky question.
Yeah, probably the simplifier is some magic thing that has lots of heuristics in it.
Yeah,
Because
maybe it
the
does
simp
because
will use like what already have. So even if you use simp, I think with the empty list, it will use, there's some predefined, you can label lemmas with simp, and it will add it to the simp database. So just because it's an empty list, it doesn't mean it does nothing. So there's already a bag of stuff which is already there. These are just extra things. So I
If
don't know if
we
they get applied
No, but
first or they
remove
get
these
applied
flags,
first.
does it still work?
No, it won't work because it will only apply this database of theorems. It won't apply, it won't do unfolding, is my reading of the documentation.
But refold does unfolding, which is, well,
Yeah.
Yes. Only if it completes, right?
yeah.
Yeah. So you can mark other theorems with the @simp attribute.
But what
if
if
want
you?
to be used in the
I
simplifier.
was thinking that what if you give as a hint 2 terms with the same type, but one is the proof, maybe the inefficient way, and the other one is the efficient way. Well, of course, I don't know how it works in the inside, but maybe if it selects the first option, the term that construct this at the end is inefficient because just took the first and not the second one. So maybe the order actually matters. But yeah, I think it makes sense.
You have to look at the implementation of the tactic.
Yeah.
It's probably not being driven by like any hints about performance or efficiency.
Yeah, I don't think it can handle that.
Okay.
Okay.
That didn't work. It's complaining about something. Can you hover over the error?
Really? Let's just see.
Oh, maybe we need to give it the
Awesome.
type. I don't know. Yeah, I don't understand.
Oh, what if you bring is right identity as a thing?
Oh.
No, if you swap them around, like it's fine with is right. This one. Let's just put them right next to each other. But this one, oh, blasphemy. Like, sorry. You used to semigroup. Ordering EQ equals X, right? And then
Where is this implicit lambda?
yeah, because let's bring these things down. so we can see them. Okay.
Is ASOC, is left identity. Where's '83? What's on line 83? Because there's no is right identity field there, is there? Or is it that's because it's telling me about his right identity?
Yeah. So, okay, if we put these on separate lines, maybe that helps.
It has type. Okay, so the only, I mean, it doesn't account for the fact we haven't got an error on the right identity, but there's no for alls on the definition of monoid. So maybe there's some difference there.
Okay.
Because
you can do this, right?
But it's being somehow implicitly added for the right because the X comes first or something. I don't know.
Yeah.
Yeah.
That fixed it.
So yeah, something implicit. So the way that it's adding those for alls is different.
No.
Oh, but now
if you remove it, right?
Maybe they're both broken. Okay.
Yeah,
So it's just only giving us errors for one, but they were both broken.
Yeah.
Okay.
So that's okay.
And there's something blah 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 implicit lambda blah blah blah. So maybe it's better just to make it explicit. Yeah. Okay.
Yeah. Not so they weren't equivalent.
No.
I don't exactly understand why. But yeah. We did it. So I would like to know why structures are preferred over classes. That's for me very interesting. I don't really understand.
Yeah.
I don't have an answer to that.
Okay. Well, I think I also can't answer the reverse question. So,
well, Jan, you already gave a couple of arguments, right? That you have access to the structure when you want to reason about it. Maybe that is a reason.
Why would?
Yes, I found instant. Well, I mean, my argument was more like, do you want to have how much information do you want to have in the signature, and how much information do you want to have as fields, rather than class versus structure.
Yeah, I sent you a picture, Jan, but like so as I said, Walter, I think the distinction is that you want to
with the rest.
That's the point. I'm using my wife's computer, so maybe you can do it.
Yeah, I'll do it.
Yeah. So in my experience, it's much easier to encode it as you did here, as a structure, because you have this is like a Sigma type, right? So if you want to prove stuff, it's much easier in this way than in the other way, because you have a type parameter, for example, in the definition, and then you are defining predicates to characterize your objects, right? But you need to carry with those proofs all the time, and maybe you want just to discard things along the way. So it's much easier if you just have access directly to the field, like carrier, and then drop whatever thing you have inside. So this way is more convenient from my experience for proving stuff. But so the picture that I sent to Jen is from a paper about category theory in AGDA. They have this.
Sorry,
They have the same discussion.
Sorry, where is the picture? Is it in the Twitch?
I send it in WhatsApp.
Oh, in WhatsApp.
In the WhatsApp. Yeah, I could use that. We have so many. We should open a Discord
so
server.
many different.
Then it would be.
Oh no. Okay.
We could have Slack, Discord.
Come on, yeah, we play Slack and
Mastodon,
Discord.
everything.
And Twitter.
Yeah.
Yeah. No, Twitter we will need to pay $1 to.
Oh, we need to pay
Elon Musk.
Musk for that. Yeah.
Yeah.
Okay.
So
Predicate
this,
versus structure. Okay.
this is from a paper where
But-
the authors formalized category theory in AGDA, and they had the same discussion. They have other design choices, but
if I understood it correctly, this is not about class versus structure. It's
no. But I mean, we have here, for example, the way that we have. Well, class. What is a class actually?
A class
In
like
simple terms.
an interface.
For me, it's like a record as well. You have access to these instances, but
yeah, like
yeah, what exactly is a class?
So
For me, it's a record.
it's like a type.
well, it's like some set of definitions that then you can have some instances of it, and I guess you have some special treatment in the inference algorithm for those.
Yeah. So you can say,
Right. I mean, in Cog you have these canonical instances, or what they are called. I don't remember.
So yeah, I think like it is basically a record, but it can be inferred, like with
Yeah.
which instance it is. So you can like say, hey, I have this thing that can concatenate things, and I take a list of monoids, and then I don't know what the instances of the monoids are. I don't care. I can concatenate them because they have a mappend operation. So I can just, so then I can use the same thing to concatenate a list of strings or to sum a list of numbers.
Yeah. But this is just a description of a type that has this operation and these properties, whatever. But these are terms of this type.
Yes.
And instances are just terms of this given type.
I found this paper. I put in the link. I think it's
Good.
discussing exactly what we are discussing here.
Yeah.
Link in the Zoom chat.
Okay. Just please put it in the Twitch chat so everyone has.
I don't have Twitch. I put. Oh, come on! I asked him for verification. To give all the data. Come on. I put here.
You post it in the.
You can delete after.
That's so smart.
Okay, I put it in the Twitch chat. There you go. Okay.
Maybe for discovering instances, one approach should be better than the other. But
Okay, where do you want me to scroll to?
I was reading the first part, the introduction, why they need, and the approach will look like they say the Lean mathematical library mathlib has settled on the use of type class pattern for representing structures, implemented through Lean mechanism or instancing parameter. So, type classes is really, if you want to do the Haskell way, is using class and instances. Look like. But look like Lean4 is actually moving away from that.
I don't think so.
As of February 2022, MathLib contain over 600 classes and over 8,000 instances. Wow. I don't know, I think you should read this and, or maybe it's not, actually I find very instructive this way to try to do both. Is, I don't know, as since we are learning Lean, we can, and then we can find our way. I don't know.
I can show you what the classes would look like, since I've prepared that in the oven. So
Page 4 of this document.
Oven ready.
So all right. So you have sorry, let me just check. All right. So you have your class of a Magma. Okay, and we don't need this, but I added this little infix operator for it.
Oh.
And so this was our legs function.
65 is the priority, right?
Sorry?
Infix is the priority, the number 65. Yes. Okay.
Yeah, let's not focus on that too much.
When you ask for
yeah, so I just made an instance of representation so I could read it. So here's the instance of ordering that is a Magma, right? So we had, where is it? We had this.
Yeah, I think it's probably there are more infrastructure around the instances and classes that aren't wired in the type checker or something like that. But for me, at least, it's just tinted sugar for records.
Yes.
Yeah. Like.
So yeah, here we have our semigroup. And then we have our instance of our semigroup. Because so here, for example, right, we don't need to say, so our semigroup said it extends Magma, right? And we've already created an instance of ordering for Magma. So here, for example, we don't need to say that ordering extends Magma.
Yes.
It's done. Like, so there's like this database that's being updated for us that we don't have to. So with records, we would have to bring this all along,
exactly.
like we did here, right? So this syntactic sugar does do some nice things. And then the same here is Monoid, right? It extends semigroup. So again, like the structure parts were beautiful, right? It's very much similar because both have the extends thing. And then yeah, we had, but when we implemented it in, these were kind of similar, right? So again, like we don't have to mention that it is a semigroup because this is already done.
Right.
And then, but the real syntactic sugar, I think, comes with using it, right? Where a record you have to pass in, but we can just pass in ordering, right, into some function, and then we know we can use all the monoid operations on it. Like everything about the monoid thing is true, where otherwise we would have to pass in the ordering legs monoid. Like, but that's like, yeah, it is just syntactic sugar if we were.
But if you make in whatever term that you are defining in the type signature, you make them implicit, and then you don't really use them. Sorry, you are not really explicit. Maybe the inference algorithm in Lean can infer that thing.
Yes.
And then I don't need instances. Maybe, I don't know. I'm guessing that it may work.
What do you mean?
Like, for example, you are defining a term and then an implicit. Do we have implicit, by the way? I'm assuming that we have implicit arguments.
Yes.
And then you define, okay, I have here a monoid. No, actually, I would need an example for saying what I'm trying to say.
Yeah.
Like, maybe if we just try to do something with these instances, and then we compare with the structure approach.
Okay, so let's go.
I need to leave early today, so
Cool.
I'll watch the rest of the stream some other time to catch up. I'll see you in 2 weeks.
All right.
Cool. Yeah,
See
we
you.
are. Oh yeah.
Bye then.
Yeah,
Bye.
not 2 weeks. A month.
Okay, a month.
Yeah. And then 2 weeks again.
Okay.
Yeah. Sorry about that. Or
Are you creating also GitHub, right? With all this code, right?
I will push some of it. Yes. I will clean
Thank
it.
you. Bye.
Thanks,
Bye.
Jeff. Bye.
I think it should be nice to keep this 2 implementation, and I like this comparison.
I like the having as many implementations of the same thing. Like,
Yeah, we start learning, so it's
with
very powerful.
especially, you know, where are we? Oh, I do like whenever we want alternative proofs to just use ticks and reprove the same thing as many times we want. Like that's because I think it's good to see equivalent things. It helps you understand. All right. Well, yeah, it also has been 2 hours, and this is kind of as long as I said we would go. Because I don't want us to like tire out, feel like we're going to be super tired after each of these sessions, except if we want to be. So I'm like, we can try to use it, or we can try to use it next time. What does everyone think?
Yeah, just thinking about it, I think that's what so definitely in Haskell, the type class resolution ends up passing in a record with the resolved the resolved instance.
Yeah.
So like passing in the resolved instance, even if it can be inferred, it's probably equivalent to using the type classes. But you're doing the work of the compiler for it. You see what I mean? Because it's trying to figure out what record of functions or fields need to be passed into the function.
Yeah.
Based on the constraints of the type class.
Yeah. Yeah. So my reflex went to classes because I know these things are classes in Haskell.
Also, I was thinking that in Agda we also have instances, but nobody is using that. Also because it's a bit fishy how it works. So we have managed how to handle all these kind of algebra things that we're doing here without using instances. So you can survive.
Wow.
But
I
maybe
think some people, even Haskell, in Haskell, people don't. There are certain people who don't use type classes in Haskell even.
Yeah.
What?
So
No way.
So I feel like that's my perspective on it here. It's like maybe you could get away with not using them, but you end up having to re-implement what the compiler is doing for you. If the support is good, like for this resolution of instances.
Yeah, and it seems to be more powerful than Haskell's, so might be pretty good. But I don't believe you, Paul. Like there's no way. So yeah, because then they're not writing programs that do anything. They have to use the IO. Like
look, there are people that are talking, probably vanishingly small number of people who've used Haskell from the very beginning, because Haskell didn't have type classes at the beginning.
Yes. Okay.
Or monads.
Yeah.
Or any IO.
Yes.
So it's like I don't want to use IO in Haskell. It's so dirty. Yeah.
Yeah. Okay, so I think
Or maybe we should pick up next time and you try to use classes.
yeah, everyone's sufficiently tired, and I can upload all of this to GitHub, clean it up a bit, and upload it, like both the structure and the classes version, and then we see what we end up using. Doesn't matter. Like they're both interesting, I think.
Yes.
Mm-hmm.
What
All
else do we need to start to do your proof then as a basic structure? I think we are done, right? We have the ordering monoid and stuff like that, so we can start to work on that.
Yeah. So given all these structures or classes, we need to pick one.
Yeah.
Then
Oh, we can have always two versions.
Oh,
No.
Exactly. No.
I'm happy with having two implementations in the repo, but then we need to pick one. Like it's nice to see things are equivalent, but you can't build too far.
I was joking.
Yeah.
I was definitely joking.
Yes, I just wanted to be sure that anyone who doesn't understand sarcasm was on the same page. Yeah.
Oh, if you want really to get crazy, you can do one stream with class, one stream with structure.
Yeah. Yeah, no. But we need to pick one, but then yes, we have everything we need to continue the proof we started in the first session. We just add this little this one.
Yeah.
And then we're done. So
65. Okay.
it's the same as plus. I copied and pasted plus. So like
Okay.
you need to pick some order of precedence.
Yeah.
I don't know actually how to do that, so I just pick
Yeah,
copy
we
a
need it.
number, which I think is exactly what you shouldn't do. I think you should pick your own number, but
Mhm.
we'll fix it
Okay.
once we run into a problem.
All right. Thank you, Walter.
No, thank you.
That was great today. Thank you.
Yes,
thanks.
I learned a lot, so thanks.
Me too.
And thank
Thanks.
you, everyone, of course.
Yeah.
Thank you. Bye-bye.
Thank you, and have a great rest of your weekend.
Bye, Paul.
See you, Jonathan.
Inside joke, I expect. Okay. I need to stop the stream somehow. Wait, no. That's not now.